Hi everyone. Good evening. Good evening if you're in India. Good morning if you're elsewhere. Welcome to this webinar where we at Blue Sky Analytics and the Indian Youth Climate Network are going to try and discuss certain issues that we think are important in the run-up to COP26. I think the idea that we had is that since a lot of people will be going to Glasgow physically in November, and a lot of us who are not going will still be tracking the news online, what we were thinking is that this can be some sort of a meet and greet so that we know some of those people who are going. We either meet them for coffee when we are in Glasgow, or we follow them on social media over the next couple of weeks. And the title for this webinar today is whether Indian tech and big data can trigger climate action. And the three people that we have to be speaking on this are people who I think are straddling the worlds of, well, they're straddling the profit and the non-profit worlds and have been in the climate space for a very long time. So I think they will have some good ideas from the work that they're already doing and the work that they want to do in this space of climate tech and climate action. Now, what's going to happen at COP26? You know, in some ways, it's what we've seen happen over the years, which is that developed and developing countries are going to go head to head. We're going to hear passionate speeches from leaders in small island nations, kind of rebutting and rebuking leaders from big developed countries. And all of that is going to happen at a very high level. It's going to be high octane, high volume. And amidst all that noise, I guess the question that we are asking here today that we want to discuss in this room is whether there is space in all of this noise for young people. Whether we qualify as young people or not is the topic for another webinar, but whether young people like us have good ideas and whether there's space for that in this climate conversation. So when I say young people and young ideas, what I mean is contemporary thinking in the space of science and technology, whether big data and specifically here climate tech has any solutions to some of the problems that we currently face in this climate conversation. So let me just introduce the three people we have speaking here today. Gaurav Madan, he's in Oslo right now. He is a member on the board of directors at the Indian Youth Climate Network and also a researcher in physical oceanography and climate change at the University of Oslo. He's been working with in situ ocean observations, regional climate models, and Earth system models for 5 years in Canada and Norway. His interests are in large-scale ocean dynamics and modeling, climate policy, and public outreach. Our second speaker, Rishabh Khanna. Rishabh is in Stockholm right now, and he is the Chief Impact Officer at Earthbanc and a steering committee member of the Initiative of Land, Lives, and Peace. He's also one of the co-founders of the Indian Youth Climate Network. And for 10 years, he has focused on applying new economic and business models in accordance with the planet. And he's also done a lot of other work with organizations, including the African Development Bank, the UN Habitat, Ministry of Defense in Sweden, and a couple of ministries in India as well. Harsha Devulapalli, he is from Blue Sky Analytics. He's the product lead. And he is also currently leading the development of Spacetime, which is a spatio-temporal mapping platform. And before this, he was a journalist. He still is a journalist and a developer with Mint newspaper. And currently, he is pursuing a master's degree in data journalism at Columbia University in New York. So Harsha is in New York right now. And my name is Anu. I am a journalist. I've been covering public health for the last many years. And I am new at Blue Sky, going to be doing things like this podcast and basically looking to have wide-ranging conversations with people in the climate space to figure out what the conversation is and where it should be going. So let's just get right into this. And once again, I'm just going to request everybody to mute your audio, but feel free to keep your video on. It'll be nice to see all of your faces. I would also recommend if you can change your name on Zoom to indicate your name as well as your organization, so that we can network. I mean, where, and how else are we going to be able to meet people? Feel free to keep putting in your thoughts, your opinions, your disagreements, your whatever it is in the chat box. And speakers, of course, I think we will try and keep it. I will try and keep it very tight. And our three speakers, if you can keep yourselves to like 7 to 10 minutes, I will start waving wildly if you don't. And this is also being recorded, by the way, and the recording should be available later on. And let me begin by asking Gaurav if he can start with his points that he wants to bring to the table and his presentation.
Thanks a lot. Let me quickly get my screen up. So the title for presentation today, of course, for all of us is how India tech and big data can trigger the climate action. Now, the functional word here is climate action, and in order to decide the climate action, you need to know where exactly we want to work with. Once you have identified where you want to challenge things, that's when you can bring in your expertise and get the job done. So I'm a physical oceanographer at UIO, so I work with climate models. These models are used to generate reports. So initial thought that I had while making this talk was how we are accessing data which are publicly available right now, and making all these pathways and how they are changing the climate action. But then I came across this news report earlier today that talks about the lobbying that was expected to happen between the developed countries. And this triggered a chain of thoughts that it's important to understand what IPCC report is actually trying to say, because there is a lot of buzz around IPCC report in the media. Oh, this is the code red warning, and how this is climate crisis now. But in reality, IPCC report does not mention even any of these words at all. If you read through those 4,000 pages, if you care to read those 4,000 pages. So I just wanted to take you through what to make out of that report that you can use to trigger that climate action. So back in 1938, just before the World War II began, well, those of you from that time would know this guy, Guy Stewart Callender. So he was a steam engineer who saw that climate, the earth is warming based on 147 station data he studied, as carbon dioxide is increasing in those stations, which was pretty interesting study at that particular time when we had absolutely no resources. And then 30 years later, Suki Manabe, who by the way won Nobel Prize this year in physics, he established using computer models that when we double carbon dioxide, we see an increase of temperature by 2.28 degrees, and if we halve the carbon dioxide, we see about a similar change in the temperature on the surface. And this is not just restricted to surface, it's for the entire atmosphere. And then began these reports. IPCC was set up in 1988, UNFCCC came into existence in 1990, and the first report was also out in 1990, and in 1995 onwards, we had these COPs going on. 8 was hosted by India, and now we are heading towards COP26 in 10 days. In 1978, Charney suggested that computer models cannot be accurate between 1.5 and 4.5 degrees. That's how far in accuracy we can go. And that's pretty much what it stayed in the initial years when we started working with the climate models. But there is something special that happened with AR6, the assessment report 6, which we released in August. We were able to achieve some amount of accuracy in last 50 years almost. So that's how slow the progress has been in the climate models. And once we look at this is again, CEO stripes is something which is pretty common project that many people must have seen for their cities. This is where we are at the moment, if you can see my mouse. And this is the decision that we have to make today at COP to decide our future. Now, IPCC Assessment Report 6 is not a work of just one institution. These are all the institutions that have contributed significantly. And this is a special moment for India, a special report for India, because this is the first time an Indian model was a part of this report. And India made a significant contribution to that. My alma mater, but that's not where I am right now. I'm working with NCC, registered in Bergen, but everything happens in Oslo. I don't know why it's registered in Bergen. So my talk generally will be about how we can use IPCC assessment report to drive this climate action. When the report came into existence, this is one picture that was everywhere. We were showing that this is code red. We are breaking the barriers, reaching 2.5 degrees Celsius, and that's how it's going to happen. And by the way, when IPCC Assessment Report 6 began, we didn't know about Paris Agreement. So no promises made in Paris Agreement form any part of the IPCC report. So we don't even know what kind of changes would that deal with. But this report has something special, which were SSPs instead of RCPs as they were in the previous report. Now it's interesting to understand what these SSP really stand for. So we see this in 3 categories: low emission, medium emission, high emission. Why it is important to remain under 1.5 degrees. Right now, we are like twice the probability of droughts and heavy rainfall, and this increases dramatically as our net temperature increase about at the end of century is increasing. So this largely calls for the action which is needed right now. But what are these SSPs that are telling us, oh, do this, do that? How are they designed? It's important to understand that. Now, these SSPs are the pathways which climate models, all of us, I'm working with NORE-ESM, we got the inputs for, and they followed a pathway to finally reach at the end of the century, which is year 2100, to see how much warming we'll have in different pathways by the end of the century. It includes the mitigation processes, it also includes the adaptation processes, and it kind of tries to find a balance between mitigation and adaptation in a sequential manner. So these SSPs are made in a very complex manner. All the inputs are taken from different sources which are going to drive these integrated assessment model, which take into account what all processes are happening on the ground, how people are seeing their development, how GDP is being grown in different countries, how its trends are. Is it fossil fuel dependent? Is it still or it's now developing towards greener technology? All these inputs are taken into the account, and then emission pathways are given, and these emission pathways act as input in these climate models. Now, my job in this particular session right now, in the first few minutes, I just wanted to set up the platform for Rishabh and Harsha to pitch in where they stand. So what they are working right now is kind of modifying the input that is going to integrated assessment models. They are trying to change the emission pathways, really, using the cutting edge technology which we have available today, which you call climate action, so that these pathways can be changed and we can bring these SSPs, which we are going to talk in like next 1 minute or two, down to what Paris Agreement really calls for. Now, these SSPs, they are very simply designed, but yet pretty complex. On the right hand side top, you can see what these different pathways are going to lead to. So SSP1, these two are SSP1, SSP2, SSP3, and SSP5. SSP4 has been dropped largely because that's largely based on inequality between developed and developing countries. SSP1 is largely based on the sustainability, where we are assuming that we have already achieved the peak, and now from here on, let's just take the road of dropping fossil fuel and just continuously working on the green technology, which I believe should be the path that ideally we should be taking. SSP2 is largely the middle road, where we still see a consistent increase in carbon dioxide emissions, and then we'll take our time to get into a zone where the emissions are reduced. We are giving some breathing space to developing countries, and developed countries are taking the major burden. SSP5 is the one which is the most starking, which is fossil fuel dependent, where we are right now. You are in India, if you are seeing the coal shortage which is going on, and this is going to dismantle our development by changing our pathways in the sense that our power generation is still about 70% coal dependent, which is changing, but still not as swiftly as we would intend it to be. And the funny thing about all these pathways is, if you see at the bottom, the only pathway that can really achieve this 1.5 degree goal is the SSP1, which calls for sustainability, which calls for green technology, which calls for climate action through different technologies today, right now. But and all other scenarios, which are SSP5, SSP3, and SSP2, where they give breathing space to developed countries between 2020 and 2030, and developing countries all the way to 2040, 2050, they are crossing this barrier of planned 2 degrees in Paris Agreement, which is going to be catastrophic, which I believe Rishabh and Harsha is going to point to as well in their presentation. But again, these narratives are important, which are devising these pathways. And these pathways are largely dependent on what our objective is, which is development, and which in turn devices what all changes we can make to make it as green as possible. And once we combine these elements, we get one not so technical but a major narrative. And then these narratives are pulled in these particular feedback pathways. And climate action does not do anything to this, it does all to this. This is the input that generally is taken into the account when scenarios are formed, and the driving factors are taken into the account for these climate models, results that you can see in IPCC report. And all you can do is change this energy demand, energy supply, how you are supplying the energy and how this demand is being met, how that energy demand is being used, how land use cover is changing, which in turn will have their impact on greenhouse gases emissions. Air pollution is a big issue in Delhi, which must be taken into account. And the costs, how easy it is to, or how difficult, how costly it is to move from fossil fuel dependency, which has been forever, to the greener technology, which again has to be devised by a proper climate action. Now, the takeaway from IPCC report is, yes, we are warming, and we are warming very fast, entire planet, largely. But this is not happening everywhere equally, first of all, and some places are experiencing cooling. So one of the biggest argument that maybe developed countries or climate change deniers make, oh, it's not heating up because they go with localized data set. We must understand, first of all, it's not changing similarly everywhere. Some places are heating up much more rapidly, like where I am right now, it's heating much faster than it is heating up in Delhi. But the mitigation steps that we need to take are largely the same, which again divided between developed countries and developing countries. But adaptation is where the world is divided. Nations, the island nations in specific, their adaptation processes are going to be much more different than adaptation processes that probably Norway would need, or Sweden would need, or India would need. And even within India, the adaptation pathways that coastal region would need compared to Delhi are going to be entirely different. Although the brunt, they are all bearing the same brunt, and they are all contributing more or less equally towards all these changes happening. So while the world has to unite in the mitigation, which again COP26 is going to be all about, the adaptation is something which is very regional. And this is where the Green Climate Fund, which is being talked about, which I'm very pessimistic about that from at least for COP26, it's going to play a key role. And India is one of the leading nations in developing countries. India has the technology, India has the wherewithal to invest in the greener part and also outsource it to rest of the developing countries. So this is the time for India to put their step down, come up with the challenge, take up the challenge, and come up with a pathway, so to say, in order to move forward and take the world and take the developing nations challenge forward. So I believe the focus right now should be not on SSP1, which is 1.5 degree, which has slipped away sadly from our hands. The focus should be on the central pathway, which is SSP2, where we should push the high income countries towards much lower than the current targets that they have, and allow these other countries, which are largely low and medium income countries, India is one of them, to allow them some breathing space, and so that they can catch up by year 2050 or so. And Earthbanc and Blue Sky Analytics, companies like these can help in technology advancements where we can make this slow mitigation process, where dependency on the fossil fuel can be slowly reduced and our demands can be met by renewables, and which is kind of a middle of the ground scenario. But there will be people you will come across, I believe, youth largely is focused on, where we need very strong measures right now, minimize everything today, move to sustainability right now, which is dominantly not possible. It is economically not feasible. The world is recovering from the economic breakdown, almost a breakdown that they had due to COVID. This is a very less likely scenario that we are going to see. So I think even in the meeting that we had like 2 weeks ago, where all the climate scientists were sitting, I propose that IPCC report is going to really dent the kind of negotiations that us developing countries were going to present in the COP26. But that's where we stand. 1.5 degrees I believe developed countries have rejected that particular goal and they have moved to 2 degrees goal, which is going to be catastrophic. This means now the investment is not only needed in just mitigation, a dramatic increase in adaptation is what we need, and that is very region dependent. So read through. I
Gaurav,
assume all people.
just thought I'll just come in there.
Yeah.
Some questions have come for you in the chat box, but we'll take all of
Okay.
that towards the end.
Okay.
And so I just want to ask you, maybe we'll do another 2 minutes and then we can move to Rishabh.
Yeah, I'm done almost. So yeah, thank you. So again, SSP1 scenario is where we have to make all the changes. It is the call of today where we have to move to sustainability, stop fossil fuel consumption entirely by the developed world and to very little extent by developing world, which is very, very less likely. And in my opinion, that would be a pathway that we cannot practically follow. It is where we have to go, but it is not practically feasible. So I will stop here, and I would love to take the question, but as you said, Rishabh will step in right now, and I'll take the question.
Take that towards the end. I also just want to add, Gaurav, I remember you telling me that you were part of writing the IPCC report. I think in 2000, you contributed in some parts, right?
Yes. So since I'm working with IYCN, so people who write the report, they are the different set the people who develop the model. So I am working with the ocean model of that. So my outputs are used by people to write the report.
Okay, fabulous. Okay, super technical stuff. A lot of new stuff for me, really. But good to hear all of this. Let's get Rishabh now. Rishabh, are you still here? I don't see you anymore suddenly.
I'm here. Can you see me?
I can't see you. Wait, have I done something wrong? Okay, I can see you now. I can see you and hear you. Go for it.
Yeah. Great. Well, thank you, Gaurav. That was a really great and comprehensive presentation. I'm going to try and simplify a little bit because that's my job. As in a company, we have to simplify things for the common person. So yeah, I work for a company called Earthbanc. We are a climate fintech. Can everyone see the screen? Anu, are you able to see?
I can see it. I can see it.
Yeah. So we're a climate fintech. And we think that there is a lot of possibility. What Gaurav said, like we come from the sort of group that we believe that, of course, we have to draw down the carbon, and nature-based solutions is the way to go. I mean, of course, investing in renewable energy is great, but nature-based solutions have a lot of adaptation and co-benefits, development benefits that renewable energy does not have. And there is a challenge to get investment into nature-based solutions. And by nature-based solutions, I mean transitioning the way we do forestry, transitioning the way we do agriculture, restoring these vital ecosystems. I mean, if you just recently see what's happening in Kerala again and again, and it's mainly because we have destroyed a lot of our Western Ghats and a lot of the forests in places like Kerala and other parts. And if we want to invest in these nature-based solutions, we need ways to measure that. And that's what we offer in Earthbanc. So to avoid runaway climate change, as Gaurav mentioned, broadly speaking, we need to reduce about 30 gigatons to go back into the 1.5 target or 350 parts per million. And we have a time duration. We have to do it in 10 years. There is like a set time to do that. And what, as I said before, nature-based solutions like forests and agriculture is the way in which we can draw down those emissions. Because remember, even if you put a solar panel on your roof, that solar panel is not taking in the CO2. But if you plant a tree, if you protect your trees, if you change the way you do agriculture, that is actually reducing your CO2 or methane. And in fact, methane is going to be very prominent in the coming COP26. And as you know, methane is 20 times more potent than CO2. So this is what happens traditionally when you go to do verification. You need to go to the site, you verify, you measure the length and breadth of a tree, you count the number of trees, and based on that, okay, one tree, takes in 25 kgs of CO2 per year, and this land had approximately 1,000 trees. You multiply, and then okay, this piece of land can take in this much of carbon dioxide. But of course, it's manual, it takes time, and it lacks the accuracy that's really needed. So what are we offering? What are we offering is like, you could say almost like a face recognition of trees, where the satellite AI is essentially counting the number of trees on the land and coming up with a figure of how much carbon is being sequestered, thus making it very easy for someone who wants to pay for that carbon. So let's say it's Shell or it's BP or it's Reliance, whoever who's having an enormous emissions. And of course, they have to take their steps to reduce the emissions, but there will be certain emissions that they cannot reduce. And for those emissions, they can pay a farmer or they can pay a owner for reducing those emissions for themselves. So there's a lot of these projects out there. If you look at the carbon market, it's been around for a while. It's being predicted to be over $500 billion in the next coming years. And what we are helping companies, investors to understand how to pick the right ones. Because if a project, for example, hasn't been audited for 5 years, especially because of COVID, let's say in the last 3 years, no one has done a site visit, we use the satellite data to make sure that the claims are accurate in terms of additionality. Therefore, the additional carbon storage that they're making is there, that there is no leakage, so there is no risk of forest fires or deforestation. And also there is the social impact that the project is claiming. And that allows investors who want to be carbon neutral to be more sure that what they're doing is actually happening rather than investing in a carbon bubble. So the AI MRE that we offer makes it really cheap, like it like 0.04 cents a ton of carbon for it to measure. And therefore it makes it very easy for small landholders. So 500 million holders in the world are small landholders. Almost 70% of Indian landholders, people who are working with agriculture and forest owners, they own less than a couple of acres. And this is why the verification technology makes a lot of sense, because suddenly these small landowners can now sell carbon from their land. So today, if they were doing organic farming and paying a lot for verification, now they can actually get paid for the carbon that the organic farm is sequestering and suddenly become profitable. This is how the certificate looks. And we have customers like Telia and others. And of course, there is some amount of ground truthing where like farmers in Meghalaya and Sundarbans, where we are working, put up pictures of what they're doing, how they're protecting the forests, and that helps us to also verify the satellite claims. This is a project we are currently doing in Sundarbans, wherein we're not only helping them to sell the carbon, but also issuing bonds and green bonds where we can get in more investment into protecting such vital ecosystems, which have very important adaptation benefits as well. Because in the Sundarbans, where I was there earlier this year, we could see that places where you had mangroves and embankments, people got sheltered from the cyclone 4, which hit last year and the last year. And places where you didn't have embankments, all the local infrastructure was destroyed. So yeah, that's I would say that there's a huge potential in this area. The voluntary carbon markets are growing in India and in globally. And so we think that banks and financial institutions in India need to take this very seriously, both in terms of accounting for their carbon. We did some work with MasterCard and Swedbank, but I think we could definitely work with other companies. Like we've been talking to some people who know people in SBI, for example, and NABARD, which is also lending. And these companies want to make sure that the data is accurate. And that's where I think the satellite technology can really help them to validate the claim. So that's about it, I would say.
Okay. Great, Rishabh. Thank you. Thanks for that. I have a question for you, and Kaushal has also asked a question. We'll take all of that towards the end. And other folks can also just keep putting in their thoughts, their disagreements, whatever, in the chat box. That'll be great. And Harsha, can you go next?
Hello, everyone. All right. Uh, Thank you so much, Gaurav and Rishabh. So moving on, I'm going to actually just quickly generally give a sense of uh, why the work all of us do is important and why I think even though this is an uphill battle, I think we will win. So hi, my name is Harsha. I'm here on behalf of Blue Sky Analytics today, and I'm going to quickly talk about how can data help us with climate action. So if you look at the concern about climate change in this country, look at the chart that I have for you on the slide. So this is the Google Trends chart. So it tells you how often are people searching for terms relating to a certain topic. Okay, anybody tell me what the green, yellow, red, and blue lines are? All right, so the green line
I'm gonna guess that green is like something Big Boss related.
Fair enough. The green's actually interest in movies in India over from 2004. So clearly movies are super popular. Yellow is cricket. Red is the COVID pandemic. And blue is climate change. So if you thought the last 2 years were incredibly difficult for all of us, the interest in the pandemic was much lesser than the interest we've had in films. Obviously, the interest in cricket has dipped down because there weren't games. But I think of this as a scary statistic, considering how we know how our lives have been changed due to the pandemic. And if that wasn't able to evince as much interest as we have in movies, I am worried what will happen to us when climate change will actually hit us. Uh, Moving on to why are Indians just generally not interested in climate change? By Indians, I mean the vast majority of folks who aren't in academia, who aren't in research, who aren't in media, who aren't in startups, who want to fight for climate action. I think for a lot of us, climate change is not something that affects us right now. I don't think a lot of us who are at least, especially on this webinar, are in regions where they can immediately understand the impact of climate change. For example, Gaurav says that also is getting hotter much more than Delhi is, and that's because he works with IYCN and he's been looking at it for a while. But for the average person and also for the average person in Delhi, these are just erratic weather events that we've not understood as the impact of climate change. And unlike other problems, for example, when the COVID pandemic hit India, we knew there was a health ministry that we could blame. For the problem of climate change, we don't have a villain. Unfortunately, the villain is far too complex. And because we don't have a clear villain for it, it becomes really hard to attack that problem. And this is like a larger structural problem that Indians or people of any country anywhere in the world have with climate change. That it's not a problem that they see being affected, and humans are good at procrastinating. We hope that eventually, when something will start happening to all of us, we will do something about it. And I think one of the challenges that, at least in India, we have is a scarcity of data. I think while we do have some excellent research work that is happening in some of the top universities in the country, there are some extremely wonderful scientists who do a lot of work. A lot of this work is not common knowledge, which is a general problem that most academics face in India. Like, for example, very few people in India agree on what is the middle class. If I ask audience in this webinar and I ask you, give me a number of what middle class in India is, the numbers got to be pretty like around, I would assume 8 to 10 lakhs. Do you guys think that's a fair number for a middle class? Do you think 8 to 10 lakhs per annum is a middle class number in India? If you think so, please let me know in the chat, and I'm happy to really tell you that that's not the truth. 8 to 10 lakhs makes you extremely rich in this country. So the fact is, since we don't agree on what the baseline truth is, it becomes very hard for all of us to agree on whether something's a problem or not. I mean, that's a bigger problem in India, that we rarely agree on what the truth is. But there are some things most people in India agree to. Like, we agree that $1 is about 75 rupees. That's something irrespective of wherever you're in the world, people agree. We agree that when certain political parties won a certain number of seats, whether they won it legally or not, we agree that they won a certain number of seats. So I think one of the challenges for climate change is that we need more and more people to have access to data that is the truth in a way that they can verify it for themselves, or they accept that that's the truth. For example, when Gaurav shared the SSP models, I've done inner work in stats, but a model like that scares me because it is just so complex. And as I said, थोड़ा दिमाग लगाना पड़ता है सोचने के लिए, समझने के लिए what is the impact of that model. And the average Indian, let's be honest, does not care. And our job is to make sure that they care about this thing that will affect all of us. And that's how I started getting into thinking about data and climate change. Well, how do I know what I'm talking about? So, prior to working with Blue Sky, I was a reporter with Mint, a business newspaper in India. And I worked on a daily data journalism page called Plain Facts, where I literally looked at every possibly publicly available data set and I wrote and reported on it. So, and I've always been fascinated with climate, and I've always been concerned. And I think climate change is a big problem that we will all be affected disproportionately. So one of my interests was also to get environmental data and start reporting on data with numbers that we have. For example, one of the stories that I did as part of a climate change series in 2019 is this. On the left, you have a map that basically tells you that which parts of India are getting hotter by how much. And on the right, you have a map of which parts of India are getting wetter or drier and by how much. So for this is not data I got from an academic paper someone's published. This is data I got from a researcher who worked with the IMD and was willing to share that data with us. And it was in an Excel. It was in a format that I didn't know how to open because I didn't have Stata with me. I figured some hacky way to convert this into an Excel spreadsheet, and it had millions of rows, obviously. And then I realized that, wait, what can I say about temperature? So one of the great things about IMD in India is they've been monitoring temperature in the country for a while now. So you actually have rainfall data and temperature data from a really long while. So it's actually possible for us to look at what temperatures looked like a while ago and what temperatures look like now. Same with rainfall. So what I did was to look at the median temperature in India like 50 years ago, because climate change is happening slowly. I wanted to see like a Indian industrialization, what were temperatures like. People very often say, oh no, Delhi mein aajkal sardi hoti nahi hai, like it's not cold anymore in Delhi, or Bangalore is no longer the nice lovely place it was. So I actually wanted to verify how do people say that like things have become worse. People, like, very often it's anecdotal. People say, oh, this year there's been a lot of rain in Delhi. Has it though? So I used the numbers that we have from the IMD to verify it. This is a process that took me at least 7 days. And I had to vet it with a couple of reporters, researchers, and academics to verify if what I'm saying is the truth. And this was not a fun process. The maps look very pretty, and I'm very proud that I could do this inside a newsroom, but not everybody cares that much. And which is why I decided to transition out of journalism. So this is a pretty random picture, but I was actually giving a talk about how data journalism in India is pretty hard because you don't have a lot of good data in India. And there you can see me on the left, and behind me is my current boss, Kshitij Purwar and Jashan, who were also at that talk. So when I was presenting about the challenges of data journalism in India, and I spoke about my work, Kshitij said, boss, I think we have a job for you that might be promising. And the idea, I like the idea. The idea was, can we build an environmental India data stack, which is fancy slang for, can we make all the data on environment in India easily accessible? And for me, that seemed like the next natural step. That as someone who's worked extensively with Indian data, I know the challenges people have, researchers have in accessing baseline data. I'm not saying I want something fancy. Just tell me what temperature looked like in my city yesterday. That you can go and look it up on a website. But if you want to do any sort of analysis on it, it's pretty hard to the average person. So at Blue Sky, we had one motto, that is saving the planet with data. How do you build environmental data sets that can actually help us measure the problem that we have? And more importantly, how do you make this data accessible to people who need it? And we started building this thing called Spacetime, which is our in-house spatio-temporal mapping platform, which we want eventually to have a massive repository of environmental data. The idea is that you have, if you are interested in what pollution levels look like in Jharsuguda in Odisha, or you want to find out what tree cover looks like in Hisar in Haryana, or if you're interested in what groundwater levels look like outside Chennai, we want to be able to answer that. And we've started building this thing called Spacetime, which we want to become the default go-to for all kinds of environmental data, not just India, across the world. But this is an Indian audience, so I'd rather show it for India. For example, the screenshot you have is of Spacetime, and you can look at what sulfur dioxide emissions look like in different parts of the country. And as of yesterday, the idea is that we put out all kinds of essential integral environmental data sets with really high accuracy and for all of India, not just for some of India. We think that by making this data accessible, we can contribute to the discourse for climate action, not just for academics, but also for reporters like me who want to be able to report on environment in India. And that's where I see the work that we do is important for climate action. And thank you. I will end with that.
Okay, that was great, Harsha. You, I think, were very precise with keeping time. Thanks for that.
I had to really rush it through, but it's fine.
Yes, wonderful. So we can open the floor for questions right now. I just want to once again invite everybody to drop their questions if they have any. And if you actually, why don't you just unmute yourself and, just ask your question if you have it. And the rest of us, I'm just going through the participants we have today. I'm trying to figure out where everybody's from. I know that a lot of my colleagues are here, and maybe the rest of us, if we want to, we can put our organization names in our Zoom handles, because then I'll know where everybody is from. Yeah, I think there'll be a lot of people from IYCN here, which is exciting. And if anybody would like to ask a question, go for it. Just unmute and go for it. And I think, Gaurav, if you can also... Yes.
Can I answer this question from Kaushal?
Rishabh wants to answer, Kaushal's question. I'll just read out Kaushal's question. He asks, Kaushal is from the Hebrew University of Jerusalem, and he's asking, how do you calculate the amount of carbon sequestrated by forests/crops? Is it an average number? How accurate are your estimates? And I ask because I presume that big conglomerates would ask for precise numbers since they are paying for it. I know you've given that link to that blog, but maybe you can explain it, Rishabh.
Yeah, so basically what happens in physical verification, Kaushal, that you have to actually physically go and check out the land. And unfortunately, because you don't have that much time, you actually don't go to the entire piece of land. So when you're doing physical verification, which happens till today, it's only accurate to the sample best fit. But using satellite data and AI, because we get high resolution data from the European Space Agency and NASA, we can actually look at each and every tree on that land. So the accuracy is much higher compared to physical verification. It's of course different methodologies for different types of project. An afforestation project is different from an agriculture project, different from a conservation project. So it really depends on what kind of project we are trying to audit. And we do our own projects, like the projects in Sundarbans and Meghalaya. We are the project developers. There we have to get an external agency to look at our work, but we can also audit other people's projects and their claims. And you can look at that blog, which explains you like more details, because I mean, I can go on for a very long time explaining how this works. But the three principles behind it is additionality, permanence, and leakage. How much additional carbon storage is happening? What's the permanence nature? Like how long is this going to stay? And are there any risks of leaking of the CO2?
Okay. Thanks, Rishabh, for the answer. I actually asked this question because one of my research topics is looking at biogeochemical variables in the ocean. And the problem with variables like measuring the amount of carbon dioxide is, unless you have extensive in situ measurements with very precise instruments, it is very difficult to get an estimate. I have not come across something like your work yet. I'm surely to read this and I'll follow up with you at a later stage if that's okay.
Yeah, you can get in touch with me. We've done some work on the seagrass sampling, and yes, we do take some in situ, but the sampling requirement becomes very, very less when you're using satellite data.
Yeah, okay, thank you so much.
Rishabh, I'll just ask my question, and this is, I think, a question that I'm also trying to understand even at Blue Sky. You said that satellite data is actually making it foolproof, bluff-proof. But are there any shortcomings with satellite data as well? I mean, I understand that it's a new layer and another layer of accuracy, but are there still any shortcomings to it?
Of course, there are shortcomings to it. I mean, this is about verifying the truth, right? I mean, the truth is the truth is the truth. So there is sort of the physical, what the person is saying. Okay, a farm owner might say, I have 100 trees, right? And then there are ways in which you can look at secondary data if he can have 100 trees. But on top of that, the satellite data will show images of whether those trees exist or not. So I think the satellite data corroborates very well what the claim of the ground. The difference, I think, is the sampling. So when I say the accuracy increases, it's because the amount of sampling that we have to do, the ground data sampling, is much, much less. And because we are able to see time series data over like many, many years and very good resolution, we can also see changes in the land in the last 10 years, 20 years, 30 years. And that makes it much more easier to calculate and measure the variance, the additionality, compared to just doing ground truthing. So I don't think that, of course, there is still, end of the day, it depends on the integrity of the person who is working on it and how I'm using the satellite. But I would say, like, for example, the recent example I can give you, Telia, which is like a really big telecom company, was buying credits in the Peru Amazon forest. And those credits were not physically audited or verified for the last 5 years because no one had the cost and energy, and because of the pandemic, no one could go. But they were buying those credits. So they had no way of knowing about the project risks until they got us to do that verification through the satellite data. We didn't actually go there, but we looked at the claims of that report that were made in 2015 and saw if it was still valid using the satellite data.
Got it. Thanks for that. Harsha and Gaurav, Harsha, I know you can speak to satellite data. Gaurav, I'm not sure how much your work also deals with this. I mean, do you also kind of see this in the same light that, satellite data is allowing us to further corroborate and get closer to the truth? Or do you see problems or inaccuracies, which are fine? It's just that we should know about it and account for it.
Well, satellite data has revolutionized the way we are approaching different problems. If we talk about the times back in 1980s, 1970s, when there was very little data availability and scattered stations that used to be used for making some arbitrary analysis out of it, which was not very particularly valid for regional problems. Satellite has given us a much broader picture where we can see things happening in the real time. We have weekly swaths of entire world basically, and you have these weekly pictures, and you can see the timeline. It's interesting because recently NASA also released some of the timelines of different places in the world where they were showing how exactly these places are changing so rapidly with urbanization, and the impact of climate change as well was quite visible. So I believe satellite has not only just revolutionized the way we are approaching our issues, it has also helped us in the modeling as well, because now we have much more realistic data samples available rather than one data sample in 1 year, which was earlier used to be the case, specifically for the oceans.
So I'd like Harsha to also weigh in, because I know that some of the data that Blue Sky is using, of course, there is a satellite component, but there's also a ground monitor, ground sensor component. So am I understanding this wrong, or do you, Harsha, see that both are necessary, or do you see one as superior to the other, or how do you kind of see this?
So that's a great question. I think both have their purposes. Like there are satellite imagery is great, especially when you don't have monitors in countries like India. For example, pollution control board monitors are largely in big cities. We don't have pollution control board monitors in towns or district headquarters, most of India. So that's where something like satellite imagery is great. But unfortunately, satellite imagery is like a very top-down way of looking at things, and we'd rather always want on the ground monitors to support the truth. So we want that we have ground data to verify what we're saying. For example, in the pollution PM 2.5 smart EQ model that Blue Sky has, we use a combination of both. We use the satellite imagery to estimate the PM 2.5, but we use the ground monitoring data to verify if our model is being correct or not. We basically then use like a combination of machine learning to figure out how often is our model right or not. So I think the right answer is both. But we know that as we're not a governmental entity, we can't set up monitors right now. So for us, the easier option was to start working with satellite imagery. But at some point, if there are organizations that are willing to establish ground monitors, that'd be better. Ideally, we just say more people should be monitoring the Earth more closely.
I have a follow-up question as well. So in your in that SO2 image that you show, the data that you are largely accessing is a satellite data, is it?
That is satellite data. And so the raster that I showed you is satellite data.
Yeah.
But we can
Okay.
actually show you the monitors too, the 200 odd monitors that we have across India, what they estimate to.
But have you tried to tap into Suffer project, which is already in
That's
implementation
this.
between
Yes, yes.
IMD?
So yes.
So you are using Suffer data, right?
This is not Suffer data.
Okay.
This is we're using ESA data. No, we're using Sentinel-5P, I think. Sorry, my bad.
Okay.
If I may interject to the three panelists here, so Gaurav presumably works with theoretical climate models, if I'm correct, and Harsha is right now working with satellite tech, and as Rishabh mentioned, in situ measurements are also a part of his work. So what happens is when you have a theoretical model built on a computer or a piece of paper, satellite data is the first thing you can benchmark your model against. So that is like the zeroth order step of validation. However, the holy grail would be to map out everything possible. So, if I remember correctly about the oceans, monitoring the oceans is one of the most difficult tasks that we have because you can't put physical sensors everywhere, but we are getting a step closer to it. I would encourage anybody and everybody attending this talk to definitely check out Woodsall Oceanography Institute's recent project where they have deployed modes and measurement instruments into the Atlantic, and they plan to do it at a very regular interval in both space and time, which would lead us to building a better in situ data set, at least about the ocean, Atlantic Ocean to be precise. That's all.
It's funny because you stated that my work largely is about both models and observations in the Atlantic, and I'm actually accessing those Argo floats and gliders and mooring data at the moment to study the changing Gulf Stream at its relation with the sea ice as one of the projects that I'm a part of.
I did not know about this. I am pretty sure I'll get in touch with you after the seminar is
Sure.
over.
That's lovely, Kaushal. Thanks for that. I think there's RK Gautam has his hand up. Is there a question that RK Gautam might like to ask?
Yes, Anu.
Yeah, go for it.
This is something similar to what Anu has asked a little while ago. This question is for both Rishabh and Harsha. Harsha, having both AI analytics and the ground level monitoring, as you said, it's now, and Rishabh from the satellite imagery point of view, is there a marriage between these two methods and then make a carbon or emission heat map of the world or of a zone or something geographical, and then make projections for the next, say, 30, 40, 50 years? I'm coming from the real estate development point of view. And then if we can see those risk zones like seismic zones, and if we can know which zone is more riskier in terms of emission related impacts than the other. And maybe the question is slightly stupid or more, but then that's what maybe some of my clients are looking for.
Good question. I think that that's a question I've been asking also in some way or form. So go for it, any of you guys.
Was your question mainly to do with seismic zones, like earthquakes and stuff?
No. I'm talking about a emission heat map and then categorizing the whole geography into emission zones, risk zones. I mean, whatever level or whatever method we adopt or model we adopt. Can there be a zone classification similar to seismic zones for climate risk zones?
Okay, all right. Well, I mean, first of all, I would say that one of the challenges we have in the world today is that we try and look at things in a separateness, but the Earth is actually not that way. We actually need a renaissance in how we're looking at things. We're currently doing some work for the African Development Bank, where we are developing the adaptation benefit mechanism. And what we are seeing is that, of course, there's a lot of maps. The UNCCD, United Nations Convention for Combating Desertification, has done on the risks of degraded soils in the world. And they even have looked at conflict and how the more degraded landscapes are seeing more conflict related to water, related to land and soil. And then similar maps have been done for biodiversity and also for climate. The interesting thing about land is that it actually brings all three together. Of course, I'm sure in oceans also this happens, but the difference I would say between the ocean and the land is that the land, these degraded landscapes where the soil has become infertile, do have a massive potential to take the carbon. And when you improve the carbon richness of those soils, the productivity and fertility of those soils increase. Therefore, it would create food security and biodiversity, and therefore the adaptation benefits that we are working on with the African Development Bank. In the ocean, it's not the same case, because the more you increase the carbon in the ocean, it would increase the acidification of corals and other things. So for the land, I would say there's a lot of work done by Professor Ratan Lal, who even in the 2015, when they came up with this 4-for-1 initiative, where the idea was to increase the soil carbon on average by 0.4%. And Professor Ratan Lal said that if you actually are able to do that, that's enough to sequester all of humanity's emissions. So there is maps. You can look at UNCCD on the maps they have done on degraded soil.
UNCCD. Okay, got it. In case anybody else wants to respond to the same question, or if there are any other questions, if not, then we'll close soon. I can ask a last and final question, but I also like to keep time. So in case there's anybody really burning with something, if not, I guess, let me just close with this one question and just quick comments from everybody. In this conversation, we started off by thinking whether Indian tech, can have any solutions in this climate space. Now, I see the three of you. I see you as intelligent Indian origin individuals, but I also see you working abroad, right? So I just want to know what your kind of, at a more personal level, where are we? Are we in the right place, right time in terms of, this conflict between developed and developing countries, which is going to pan out? And we need the solutions across the board, but we need various, very different kind of, as I think Gaurav was saying, adaptation solutions will look very different in the developed and the developing world. But is all the thinking going to come from abroad? Is that why you guys are living, working, studying abroad? On a very personal note, but also link it to this political context, how do you kind of see yourself? Very quickly from all three of you.
Well, I think that what's really important, Anu, is that the developed countries have a historical sort of responsibility, right? They did benefit from this carbon budget, and they have taken most of the carbon budget. So I'm sure there is a guilt, and they do want to support people from the south to make the transition. They, of course, don't understand, what is needed and how you can sort of invest in these kind of opportunities. But at the same time, I would say we as diaspora have an important role to play as a bridge and sort of understanding both the worlds. The Indian world, I grew up in India, saw the issues. I mean, I didn't need any satellite imagery when I could see how the stream in front of me was polluted, and then, the needs of waste management. But as time went by, I felt like, India did not have the consciousness, because when we worked with companies who wanted to be sustainable, they were not willing to pay for it. And at some point I realized that I had to make a living. And so my move happened at a point where maybe 10 years ago no one was interested in this in India, but maybe now there are many more people who are interested. But definitely here in Europe and the US, the consciousness is much higher. There are like bigger budgets to invest in these opportunities, and they are looking at investing in the emerging economies.
Absolutely. Okay. Yeah. I mean, I think we are going to hear more of this kind of tension. Of course, it's playing out at a big macro political level, but all of us are exactly part of that inequality. Why we are making these choices to live abroad or study abroad or work abroad, it's part of that like large inequality. So, just quickly from Gaurav and Harsha, what do you think about this?
Well, I made the move like about 6 years ago now, and the primary reason for me choosing to move out was I'm not a policy guy, so I've never been into policy and diplomacy of these climate arguments. I am more of a scientific background, and my key interest was always the Arctic, because Arctic is changing rapidly. It's warming, it's heating up like 4 times faster than anywhere else on the planet. And in order to study the Arctic, I had to be somewhere closer to that. And that's why Canada and Northern Europe are my primary choices, so that once I'm there, I can study Arctic more holistically, given there are more resources at disposal compared to what India's work has been around these regions. And then from there, make these modeling changes so that we can then anticipate how regional models are going to come into play and how they are going to dictate the terms in terms of the way we plan these execution of the measures, the pathways that we just discussed in the beginning of this space. So that's pretty much where I am, but I do see India making quite a bit of progress, given this report had the first Indian model in as a part of it. So India is looking seriously into it. India is portraying itself as one of the leaders and not just people who would just stay on the boundaries and would eventually depend on the decisions developed countries have made. No, India is a key player, and Blue Sky Analytics organizations like these are coming up. So this shows a positive trend in the way we are looking at this climate change. It is a slow process. It will take its time, but I believe we are making the footing in the right direction.
Got it. Harsha, what do you think?
Adding to what Rishabh said, I think the problem that we have is a global problem. It's not a problem that just affects us. For me, the average person living in Kenya is as much as a brother or a sister, as much as the person living in India is. And how I see my role in all of this is that, like Rishabh mentioned, that these countries in the West definitely have access to resources, infrastructure, and the awareness to start working on it as a problem. We structurally have not been able to address core issues in our society like poverty or hunger. So climate change for a lot of us seems like a rich person problem, which it's not, which it isn't. But in Indian framework, it's seen as something that we can do once we have the bare minimum. How I see my role is to be able to use my skill sets to bring or leverage discussions about talking about people I care about. And I am attached to, I've grown up all across India. I've seen how different parts of India have been affected by climate change and will be getting worse. So for me, I see my role as an individual who is able to bring attention and discourse, ideally using resources from the West to talk about inequality that exists in terms of expectations. Like Gaurav mentioned, that the expectation on countries like ours is that we need to develop, but we can't develop too much also, because suddenly we'll be blamed for carbon emissions and all that. So I think it's a pretty political stance to be able to work for not just for one country, but for all of us. And I think it's important that it isn't a matter of where you are, but being able to use the resources we have access to make discourse on climate action a more common thing.
Got it. Okay, wonderful, lovely. Thanks everyone for being here. Thank you to Ashish from IYCN who did a lot of the coordination on their side. And I hope some of us will stay in touch. I think we should just keep talking. Feel free to reach out to any of us at Blue Sky or to Gaurav or Rishabh or really anybody who you saw over here who caught your eye. And we will see you at the next one. Thank you.